Welcome to the DIY Honda Garage channel. The DTC B1192 error code indicates that there is a loss of communication between the Gauge Control Module, GCM, and the Battery Management System, BMS sensor over the UART, Universal Asynchronous Receiver Transmitter line in Honda Odyssey models from 2011 to 2017. The Gauge Control Module plays a critical role in monitoring and displaying vital information about vehicle systems, while the battery sensor measures battery health and communicates vital information about battery status. When there's a communication loss, it can lead to issues with correctly displaying battery information on the dashboard. This problem can often be due to electrical faults, such as short circuits, faulty components, or wiring issues, which can affect the performance of essential systems in your vehicle. Proper diagnosis and resolution of this DTC are crucial for maintaining the vehicle's functionality, and it requires systematic troubleshooting. DTC B1192 signifies a communication failure as indicated between the Gauge Control Module and the battery sensor over the UART line. The primary components involved are the Gauge Control Module, which processes and relays important information regarding the vehicle's systems, and the battery sensor, responsible for monitoring battery voltage and sending this data. The Gauge Control Module is typically located behind the instrument panel, while the battery sensor is usually situated near the vehicle's battery, often attached to the battery terminals. This communication line is vital for the gauge panel to display accurate battery status, which is crucial for vehicle operation. The failure to communicate can inhibit the driver's ability to receive important alerts regarding battery health, leading to potential breakdowns if not addressed. Several potential causes for the DTC B1192 include poor or loose connections between the battery sensor and the Gauge Control Module. This type of electrical fault can disrupt the communication necessary for the systems to properly relay information. Another possible cause is a malfunction or failure in the battery sensor itself, which may prevent it from accurately capturing or sending the battery information. Issues within the Gauge Control Module can also contribute to this DTC, indicating that the module may require testing or replacement. Blown fuses, specifically the number A28 BMS 30A and number A8 7.5A fuses, should also be checked as they can interrupt the circuit. Addressing these potential issues is crucial for restoring communication between the systems. Symptoms associated with the DTC B1192 often manifest as warning lights illuminated on the dashboard, indicating potential battery or electrical issues. Drivers may also notice incorrect gauge readings, particularly regarding battery charge and other related metrics, leading to uncertainty about the vehicle's operational status. In severe cases, unresolved communication failures can lead to vehicle performance issues, affecting the overall drivability and reliability of the Honda Odyssey. Additionally, a lack of timely alerts concerning battery health may result in unexpected vehicle breakdowns. Recognizing these symptoms early can aid in timely diagnosis and repair before they escalate into more significant problems. The first troubleshooting step involves clearing the diagnostic trouble codes, DTCs, using the Honda Diagnostics System, HDS. This action resets the vehicle's onboard diagnostics, allowing for re-evaluation of the system's conditions. After clearing the codes, it's crucial to wait for at least 15 seconds to allow the systems to reset properly. Following this brief waiting period, check for DTCs again using the HDS. If DTC B1192 appears, it indicates that there's still a communication fault that needs further troubleshooting. If it does not appear, then the problem could be intermittent, suggesting the battery sensor may be functioning correctly at this moment. In this case, investigating for loose connections between the battery sensor and the GCM is the next recommended step. In the second step, the ignition switch needs to be turned to the lock position, which ensures safety while inspecting electrical components. Next, you should check the fuses located in the main underhood fuse box, specifically the number A28 BMS 30A fuse and the number A8 7.5A fuse. These fuses are integral to the operation of the battery management system, and checking them is essential to ensure that there is no interruption in power caused by blown fuses. If both fuses are intact and functional, proceed to the next troubleshooting step. Otherwise, if one or both fuses are found to be blown, they should be replaced. Should the fuses blow again after replacement, further investigation is necessary to identify and repair any short circuits to ground within the circuits associated with these fuses. In this crucial step, begin by disconnecting the battery sensor 2P connector. This allows safe and accurate measurement without interference from the vehicle's electrical systems. Following the disconnection, it's imperative to measure the voltage between terminal number 1 of the battery sensor 2P connector and body ground. This measurement provides vital information regarding whether the system is supplying the necessary voltage to the sensor. If there's an observable battery voltage present, it signifies that the circuit is intact up to the battery sensor, and you can advance to the next step. However, if no voltage is registered, this indicates a possible open or high resistance within the wiring between the main underhood fuse box and the battery sensor, requiring immediate attention to rectify the issue. The fourth step in this troubleshooting guide involves disconnecting the 32P connector from the gauge control module. This disconnection is necessary to isolate the module and to eliminate it as a potential source of the communication failure. Next, measure the voltage at terminal number 2 of the battery sensor 2P connector and the body ground. This step checks if the UART communication line is functioning correctly. If voltage is present at this terminal, it indicates that the battery sensor is operational and able to transmit data. Conversely, if voltage is absent, this could point towards a failure in the battery sensor itself or a wiring issue within the UART line, necessitating further investigation into these components to rectify the communication fault. Once all repairs and necessary parts replacements have been made, it is essential to verify that the issue has been resolved. Start by rechecking the DTCs using the HDS to ensure that DTC B1192 is no longer present in the system. This verification step confirms that the repaired components are functioning correctly and that communication between the gauge control module and the battery sensor is restored. Additionally, confirm the overall functionality of the vehicle's dashboard gauges to ensure they correctly display battery status and other critical information. Finally, a test drive of the vehicle can help verify that systems operate normally under driving conditions, ensuring that no further issues persist and that the repair has fully resolved the communication problem. To prevent recurrence of DTC B1192 and ensure the longevity of the vehicle's electrical system, regular maintenance inspections are essential. Conducting periodic checks on battery and wiring connections can help identify any signs of wear, corrosion, or looseness that may lead to communication failures over time. It's also important to monitor battery health closely, ensuring it holds charge effectively and is functioning properly. If the vehicle experiences fluctuating electrical behavior, prompt investigation can address potential issues before they result in more significant faults. Moreover, ensuring that any repairs are performed with quality components can greatly enhance the reliability of the gauge control module and battery sensor. Implementing these preventive measures will help maintain optimal functionality and minimize potential interruptions in vehicle communication systems. In summary, understanding the roles of the gauge control module and the battery sensor is critical in diagnosing and resolving DTC B1192 effectively. The systematic troubleshooting steps outlined provide a structured approach that aids in identifying the root causes of the communication failure. By following these steps, technicians can precisely pinpoint electrical faults, whether from fuses, wiring, or faulty components, and can carry out necessary repairs to restore proper communication. Additionally, adopting preventive measures, such as regular inspections and monitoring battery health, can help avert future occurrences of this error code. Ultimately, addressing DTC B1192 ensures reliable vehicle performance and contributes to the overall safety and operation of the Honda Odyssey. Please like and subscribe to the channel. See you next time!